Hi everyone, the question is, for each positive real number lambda, let a lambda be the set of all natural numbers n such that mod of sine of under root n plus 1 minus sine of under root n is less than lambda. Let a lambda superscript c be the complement of the set a lambda in the set of all natural numbers. Then, so we have to comment upon a half, a 1 by 3, a 2 by 5 or their complements, which of them are finite sets or infinite sets. Exactly one of them is supposed to exactly one of these options is supposed to be correct. So here first of all we can observe that as n tends to infinity, root n plus 1 minus root n would tend to 0. Either you can reach this conclusion intuitively, because as you increase n, this expression keeps on decreasing, and as n tends to infinity it will tend to 0. For example, root 4 minus root 3, it is 2 minus roughly 1.732, right? 2 minus 1.732 roughly, so it is roughly 0.27 or something, yeah, 0.26 something. So what about root 100 minus root 99? It will be much less. Root 10,000 minus root 9,999, it will be much lesser, yeah. Or you can actually use the concept of limit to reach this conclusion. Limit n tending to infinity, root n plus 1 minus root n is essentially you multiply and divide by root n plus 1 plus root n. So you get what? Limit n tending to infinity 1 by root n plus 1 plus root n. So it is definitely becoming 0. That means as n tends to infinity, this expression is tending to 0. So would this expression on left hand side would tend to 0. Yeah. Now you may wonder, how's that? Either again you can understand it intuitively. Root n plus 1 minus root n is tending to 0. That means root n plus 1 minus root n tending to 0 means root n plus 1 and root n are coming very very close. So would the values of sine of under root n plus 1 and sine of under root n, and this will this expression on left hand side would also tend to 0. Or you may understand it this way: limit n tending to infinity. What about sine root n plus 1 minus sine root n? Sine c minus sine d formula you may use. 2 times sine root n plus 1 minus root n by 2 cos root n plus 1 plus root n by 2, and you take mod because left hand side has mod. So clearly root n plus 1 minus root n is as n tends to infinity goes for 0, so would this argument of sine would go to 0, so would sine go to 0, so would this expression go to 0. Yeah. So that means as n is tending to infinity, the left hand side is tending to 0. And what is infinity? Infinity is essentially a very large positive number, or rather very large positive number. Yeah. So that means you can easily understand that no matter what this lambda is, whether it be half or 1 by 3 or 2 by 5, there will be certain natural number, let me call it as n naught, beyond which this inequality will hold for all natural numbers. Why? Because as you are increasing n, left hand side is decreasing further and further, and even tending to 0 as n tends to infinity. Yeah. So I can say there will always be some natural number n naught, for which I can say mod of sine under root n plus 1 minus sine root n is less than lambda for all n greater than equal to n naught, or you may say greater than n naught, doesn't matter much. Yeah. So there exists n equal to n naught for which I can say such a thing. Yeah. So that means a lambda would have all natural numbers greater than equal to this n naught. Yeah. And why are we saying so? We have already justified that as you are increasing n, this left hand side expression is decreasing, and as n tends to infinity, it even tends to 0. So beyond a certain natural number n naught, this inequality will hold for all natural numbers greater than equal to n naught. for for every such lambda. Now this n naught may be different for different lambdas, but definitely there exists such n naught for each lambda. Yeah, that means a lambda has the set a lambda has all natural numbers greater than or equal to n naught. That means a lambda is an infinite set. Yeah. That means a half, a 1 by 3, a 2 by 5, all these are infinite sets. Yeah, so that means here D is wrong because of this, B is wrong because of this, and A is also wrong because it is saying all three to be finite sets. So C should be correct, but still you may not be convinced. You may say, sir, if a set is infinite set, its complement may also well be an infinite set. It's not necessary that if a set is infinite set, then the complement has to be a finite set. It can also be an infinite set. For example, on a set of integers, if I say a set of positive integers, it is an infinite set, and its complement would be what? Set of non-positive integers. It also is an infinite set. Yeah. So how to understand that a lambda complement would be a finite set? You can understand it this way. First of all, a lambda complement would be having natural numbers as elements, and it will have it has natural numbers among less than n naught only, because for greater than equal to n naught, all natural numbers greater than equal to n naught, they are part of the set a lambda. That means the complement of it, a lambda complement, the set would have natural numbers from the set of natural numbers less than n naught only, and natural numbers has a the set of natural numbers has a lower bound. It lower bound of 1, and it is discrete 1 2 3 so and so forth. So from 1 to n naught there are finitely many natural numbers, and if this complement set is supposed to have elements from this finite set only, that means this complement set would be a finite set, because if a set is having elements or if a set is a subset of a finite set, then that subset would also be a finite set. So that's how you can say that, hey, this all these three, a half complement, a 1 by 3 complement, a 2 by 5 complement, they are finite sets. C is the answer. Thanks for listening.